guys all doing? Alright, welcome to another MATLAB professional video, pre-recorded by me. So in today's video, we're going to be going over some state space system equations and how to use some of the MATLAB functions. So right now, everyone hopefully is glad that I gave extra 2 days to do the assignment so that they can, focus so hard on finishing that second half of the assignment, or maybe finishing the first part or starting it right now. But assuming you all have finished the first part, we're going to go over the second part, which I promised to give everyone since I kind of had to take a Friday off. So it's gonna be a good video. Okay, so there's a couple notes I'm gonna do, and I hope everyone's paying attention right now. We're gonna go over this right now. So suppose we were gonna make a new MATLAB. So here's your solutions to the assignment, by the way. So here's a new point. So you're gonna do this every time you start up MATLAB, no matter what you do. So the first thing you're gonna do is you're gonna open some folder or whatever, and let's call it folder, something like this. New folder. Let's call it I don't know, EE360. Yeah, or I don't know. There you go. You're gonna create this new folder and just leave it there. You're going to create a new script, so you can either do that via the plus sign that's up here, or you can do it this one right too, but I like doing this right there. So I created a new script just to show you what you should be doing. And then you can do either this, like you can do EE360 comp homework, or assignment 2, and by your name, by David S. And then what you're gonna have to do is, actually, here's the practical way you can do this. Press run, and then it's gonna say, where do you want to save it? So we're gonna save it right here on our new folder, and call this one EE360 or whatever, CA2. I call that too, actually. Yeah, let's do that. So now this is what it's going to tell you. It's going to say is not found in the current folder in the MATLAB path. So what's happening is it can't find it in the path. So you're going to do this every time. So because I got a whole bunch of emails saying, where's my MATLAB folder? So what happened is you probably created a new file in the actual MATLAB root folder, and you probably lost it somewhere. So you're going to do this all the time to make sure everything is clean, everything's there. You're going to always change folder. Don't add to path. When you add to path, it's like saying, okay, we have a whole bunch of folders, 1, 2, 3, but then we had like some big MATLAB thing. This is like for advanced MATLAB stuff, but we're not doing that. Right now, we're just dealing with an assignment. We're just trying to get an assignment done, or just a class, like, a big class. So what I like to do is always change folder. So now you're in the exact folder you need to be, and you won't complain and say, where's my MATLAB? It's gone. And here's our assignment, so that when you do publish, let's do an example right now. We're going to publish. When you publish, I'm just going to publish whatever. This creates a new published file right here, so it doesn't get lost. You don't believe me? Let's do it again. So let's say you're going to create another folder, like trash. There we go. So here's a new folder, let's say 220 or any class, and let's go back to here. V I R is equal to V divided by I, and you're like, whatever, and you're like, okay, time to publish. What you're gonna do is run, do your runs. You're going to save it in the folder you just created, like trash. And let's call it trash. Save it there. And change folder. And as you can see, look at this current directory. This is all that's in that directory. when you publish, here's trash. There it is. Your HTML that you can give me and turn it in, and everyone can sing kumbaya. All right? Now, how do you go back to the other project? So go back to our project right here. Get rid of that. We're not going to use that anymore. Might as well delete that from my directory. Open file location. There we go. Let's delete this. Try it again. We can do that later. But point is, now we're back to our directory. How to get back to what we were working on for 360? Just press the run button. It does that for you. And change folder. And now you're back to your start. So let's begin the assignment. So I have some pre-allocated code, but before we do that, I'm going to show you a partial thing I did on the side. Homework 2. Here we go. Copy. Boom. There we go. And let's snip out this code right there. And if you want to have some really nice plots, we're going to use this little script that I have right here. So first things first is you got to clear variables. Actually, x example 1 draw given some equation lol, and then ex1 1a or 1 q, I don't know. Draw a tf ddf2. So today's example, we're gonna be going over the transposed direct form 2, because you may think, oh, the last one's the hardest one, but in reality it's actually the easier of the blocks. So we're gonna go over the easy one, and then you guys can do the hard one on your own. So we're gonna do a transposed direct form 2. So I'm just doing this to show you how I publish stuff. So I have this nice little picture I want to show you, and let's do this. Run section, boom, and oh, look at that! Here you go. Here's a transposed block 2. It's not the solution, so Dr. Stuber, if you're listening. And actually, this is completely wrong because this should be minus. So just in case someone wanted to take a picture of that, but we do have a Word document that we'll be working with. No, it's a Scribble document, so don't worry, we'll be bringing that up pretty soon. This is all generated via Simulink, which is not that bad, but it gets annoying. So that's how you print out pictures, so that when you do publish, this actually prints out. It's pretty cool. So yes, back to what we're gonna talk about. So we're gonna talk about state spaces and how to even do them. So this is all gonna be review. It's gonna be on maybe an exam. Tisk. You never know. So here's our block diagram, and I'm gonna do a quick example, but I gotta change some whack. There we go. Map 1. Boom. There we go. So I can draw. Cool. So suppose you're given some, block diagram that you've already done. Note this is minus and this is minus. There we go. So we're gonna try and do a state space. So state space is basically saying, okay, we're looking for the next state system, which is, okay, our current input. Now the next one. So what we're looking for the next one, which sounds kind of weird, but that's for a different analysis. I forget what it's really for, but this is state space systems. So here's the rule of thumb, and it's really easy for direct form to transfer, the transposed direct form 2, because it's really straightforward. You have inputs that get fed in, outputs that get fed back, and they just all come up like a fountain. So the way I think of it is I've already defined some equations right here. So this is for the regular linear time and invariant system. So this should be for the first half of the example, but this is not where we're not going to be working with this. So we're going to be working with, whenever you see a memory block, and if it's going to work with me, we're going to call this one Q2 of n plus 1. So we're looking at the previous state, the state before the memory block. We're just looking at what does the memory block have before. And then when you get delayed, it comes out as Q2 of n. And why am I doing 2 and not 1 or 3? Well, so that you can do your own work. So hopefully this is an easy way to like modify some stuff, but if you are paying attention, you know what's going on, then this video should be very helpful. And if this is confusing, then you should read the book. So now that we have this, now let's do another one. Here's another memory block. Every memory block has to have a state space. So let's call this one Q3. And note, if you follow the pattern 3, 2, 1, oh, oops. So totally not the answer, but Q3 of n plus 1. And then what happens after that? After the memory, we get Q3 of n. So now we have our state space model. So this is partially the answer to number 4. What I expect is to see these equations, but this is not the entire thing. What I expect is everyone must generate this. If I don't see this, I will take points off. Everyone is expected to get number 4 right and number 1 right, all of it right. Everything before 4 right has to be right. So how do we do this? So for state space systems, we only care about the next output, like the next state and our current input. So what we're gonna do is we want our current input or output, sorry. So this is easy. So y of n is equal to, we have this gain of b naught, b0, there we go, multiplied by our input. So let's do b0 x of n, come on. And now what's coming here? Plus q3. And there you go, hooray, you're done, yay, there you go. But what's q3? I don't know. We'll figure that out right now. But point is, we need this in this format. So let's do the next equation. So we have Q3, but that comes from Q3 of n plus 1. But what's this equal to? So this one's equal to, let's write this right here, Q3 of n plus 1, which is a next state, the next state of our system, which is going to equal, going to equal the input times b1. So here's b1 x of n, and then note this is a minus sign, so this should be minus. Tisk to those who are paying attention. So minus a1, or depends on if you include the minus sign. My friends had a debate on should the minus sign be inside the constant or should you just put it outside. This is all your flavors. Do whatever you want. Whatever. Engineers got their own models, so don't worry, we're all unique. So this is all my style, so if you try to copy it, I will catch that. Just kidding. No. A1 of y of n, and then plus this q2. There we go. But note, this is an output. We don't want to see the output in our next states. This is not good. So what we can do is, I'll get this blue pen. Note, we already have that equation here, so just substitute that. And then you get b of 1, x of n minus a of 1. That should be a 1. b of 0, x of n plus q of 3 of n plus q2. And then this is what everyone should do, because it makes the writing a little easier, is we're going to do, so note that there's x1, here's an input, so we can do this, input of b of 1, gain of 1, minus, here you go, you got a of 1, b of naught, the first initial gain, so there you go, there's one coefficient, plus, or actually not plus, I'll do minus. Yep, there you go. Oh, come on. There you go. Minus a of 1, q of 3 of n, plus q2. There you go. And there you go. That's the answer to that. So let's do q3 of n plus 1. So this is another equation to include. There we go. So that's your next state system, your state space equation for that. So we're looking at the next state of that. Now there's just inputs and our current states. So that's good. That's good. Now we got to look at what Q of 2 n plus 1. And you note there's a pattern. Actually, you won't see it right here. B of 2, sorry. B of 2, x of n, minus a of 2, q of, no. Skipping steps. Don't want to ruin the surprise. So if you'll probably catch this pattern, and then plus there's nothing because we don't have a q of 1. But the point is, you'll notice a pattern like, hey, you have this y and we're always substituting this. You have a gain of b naught and this state right here, the current state of whatever's here. So that means if you want to cheat a little bit or skip a little step, you can do x of n, b of 2, which is the current gain at that point, sorry, b of 2, minus a of 2, the initial gain right there, minus a of 2, q of 3. There you go. And that should be q of 2 n plus 1. And let's change that marker back. And there we go. And if you want a little hint, I'll give you a little hint. Note that we have this nice little term right there that always just pops up all the time. So that should give you some intuition on how to solve the actual full problem. And note this gain here too. So that should be a super hint to figure out how to solve the full n order 3 system. So now we have our state space equations, our output. Now what do we do with them? Because in reality, you probably won't be doing crazy stuff in the lectures because you require MATLAB. But what we're going to do is we're going to put this in matrix form. And this is a requirement for everyone to do too. I want to see a matrix. It better be a matrix. So let's do the state spaces. So what I defined was, we're going to start with q of 3 because, well, that's the first equation I started right here, this top equation of n plus 1. And let's put it in matrix form, q of 2 n plus 1. There we go. And we're going to look at what equations there are. So just because I can't see too much, let's do this. q3 of n, q2 of n. And note, yes, the numbers are a little off. They're different from the book, but I expect everyone knows what notation I'm using. Hint, the answer's in the book. So, yes, let's look at q3, the next state. So we have, here's a q3, which is multiplied by a1, or minus a1. So that goes right there, so a1 there. Then we're going to look at q2. Ah, we got a 1. So there we go. And then let's look at q2 for the next equation. So here's our next equation, q2, the next state of q2, which is this node right here. We have a q3 right there, so let's put a minus a2. And that's it. We don't have a q2 in there, so this is our a. Okay, we're getting there. Now we got to do a plus sign because we got to deal with the input terms. And I'm just looking at my little pre-made guide. So let's do, for this equation, the q3 equation has this term right there. So let's do b of 1 minus a1 b naught. And because I know b2, a2, b naught. And then an input, x of n. So this is what I expect to see for number 4, a matrix. And this is going to be very helpful. If you don't do this in number 4, then you're going to scratch your head on number 6. So be wary of that. So this is A and B, and I'll give you a super hint to let you know how to solve these problems. You note that this is always there, and you note that this right here So that's the only hint I'll give you. It's in the book, by the way. So don't think I'm cheating you out of something, or you're being like, man, how did you get that? Just read the book. So there you go. Now we got to get our output equations. So let's do that right here. Nope, black pen. So how do you do your output? So let's do y of n is equal to, because I don't know, I can't see. Let's do q3 of n, q2 of n, just for visual purposes. So that means we're expecting two things. And what two things do we have? We only have, well, q3, and we have no q2. So we have one q3 and we have no q2s. So there you go. That's our C. Boom. And now we need to put our input, which is literally this, plus b naught x of n. And this right here is D. And this is the answer that I expect. Well, it's not the actual answer to the homework assignment. So this, and this. So if you do want to note that somewhere in your assignment, do note that, because these will be very, very helpful for solving number 6. Not necessarily number 5, but for number 6. So these equations up here will help you for 5. This bottom, you can't really see that. This right here will help you for number 6. So let's keep that here so we have all this workspace. We're going to work with this right here. This is going to be for Q5, question 5. So this entirety right here is question 4. Question 4. So this is what I expect to see. Everything, all your work's done. So all the hand calcs are going to be in Q4, so that when you do Q5 and Q6, you have as minimal pain as possible. We don't like pain. Pain bad. Isn't that what Dr. Baker says? Like, yeah, pain's good. Nah, pain. No more pain. So now let's type this into MATLAB. But because I need to see some stuff. Oh, you almost saw the answers. Nah, just kidding. I blocked them all, so you can't really see that. So yes, let's start. Because I have some stuff already pre-generated. Let's do example. That gives me some OCD. Example 5. Yeah, 5. I'm just doing it really quick. Implementing the F2 program. So this is what I expect to see. EX5Q, I guess. There we go. Let's put our variables there. This is just preparing our, meat and cheese of the program. We're just getting all the ingredients out. Here's our coefficients that totally kind of look like the some numbers that you've already seen before. And we need to generate a time. Actually, yeah, let's just copy this. It's much more easier to explain. And I will show you what I will be doing. There we go. So this is my code that I have. This is what visually, like, I can see. This is what I can do. But I don't know about you, as long as you know what's going on. So what I have right here is a pre-link. So this pre-link basically says, okay, we have right here, man, if I can only get this pencil so far. Let's grab a black pen. We have 2 delays, so that means we're going to have a y of n minus 2. So that means we need to have at least, if n is equal to 0, we need to have at least 2 numbers to the left of, n is equal to 0. So that's why I say, okay, a pre-length, so like preparing our numbers. Pre-length is 2, just there. And then just flip the magnitude, just put the -1. And then the n length, we're going to go to 50 because that's what the example asked for. So there we go. That's how you do the time, just in case. But you could have done it another way. The reason why I do this is because I love modular stuff. I like designing code to give to another engineer and tell them what it does. Engineers like it when you give them variables and talk to them about it. So if you do make this a function, which you can, make sure you document some stuff and comment. So comment. So this is our time. This is pre-allocating memory. Like as in not like memory in the equation, memory in the MATLAB, because MATLAB likes it when you prepare stuff. And I have these two right here because why not? It's always nice to have a unit step and a delta function. And this is an input I want to do because it's mixed signals, and I'm getting mixed signals from everyone. Just kidding, no. The class is doing great. I will be grading those quizzes tonight too, so that's gonna be fun. But don't worry about tonight's quizzes. If you see that the quiz yesterday, the 25th of September, was a little don't worry too much about it. I'm literally grading on, do you know what you're doing? So don't worry too hard. So we've just prepared all our equations. So let's run that section. Now it's all here in memory. It's all ready to, play around. So the first thing we got to do is create our nodes. So we're gonna do, I'm gonna do the following right here. Okay, and that gives me OCD. Boom, because we're gonna start from the top to the bottom. And here's our output that I will put right here on top. So if you've seen Dr. Stubert's videos, what's happening, why am I doing the output on top, and then as we get down, we get to the bottom of, let's see, of this right here. Like this right here is the bottom of everything, and this right here is the top. Well, if you note that, think of it as a distance. As the farther we go down, that means the more we have to wait for stuff. So this right here is going to start generating numbers first, and then this right here might not necessarily generate numbers on time. So if you just flip it, you notice that everything just falls. It easily, the gain just falls down like a ball. Just that's the first number that gets generated. So if you do flip the equations around, you get something weird, and I've experienced it. It took me like 2 seconds, but point is, it's just this gain. X of n falls into B0 and it just falls into the output. So that's literally what happens. And then X of n falling into B2 and gets delayed, it takes a long time. So think of it like, stuff falling into a system. So B0 falls down first, and then B3 falls down last. So do be worried about that. So this generates first, Q3 generates next, and then Q2. If you do it the other way around, you will see some weird results, but just to let you know, that does get really frustrating when you don't know what's going on. Let's see. Let's do a for loop. For I is equal to yeah, okay, because I gotta get this video going. Let's do this. There we go. Some functions I made. Beg. There we go. Ending. And let's type an end. So let's create our first equation. The first equation that comes out is what I just said. The ball goes down, the input goes straight through into the output, which is y of n. So let's mark that as y of 3ss, because that's what we're doing. Did I use capital? No, I did this. So we're looking at that, the current input, which is going to be equal to b naught dot times. I'm just going to look at the equations I have here. That's what you should be doing too. This is the reason why question 4 has to be polished, so that everything falls nice and neat in your MATLAB code. Plus Q3 of f. So I put f to stand like for the future. I'm just looking at some future thing, but that's just notation. Don't worry about it. qf of 1i. And there we go. So we have a current input. That's good. And a current state. So current state, current input. That's all we matter. So this generates. So we're done with that. So now let's do q3 of f, because now we got to define what this is. And we need to look at the future input. So how to do that? Future. That's it. So you got the future right there. And then let's do the following. We're going to do the input, which is, well, the input of 1, the current input. We don't want to see any past inputs or future inputs, or else you get a big 0. Just kidding. Times. What do I have? B1 minus A1 dot times the let me see what do I have here. Oh, just the gain. So do I want to do that? Yeah, let's just there we go, so that MATLAB doesn't bark at me. So that right there is our coefficient. That's a constant coefficient minus, and you're probably saying, hey, why minus? Because, well, that's what we established here, this little minus sign right there on that screen right there, because of this block diagram that I forgot to put the minus sign on. A1 dot times Q3F, the current state of that, plus Q2 of f, the current state of that. And boom, there we go. Now we have those set up. And now we got to figure out what this is. And the only way to figure out what that is Q2 of f1. And here's the pattern that I was trying to show you. Let's do that. Boom. There we go. Yep, laziness. The current input, which is going to be multiplied by 2. A2. And notice this gain is the same. Minus 2. And notice that this current input at the top node is the same. And then this term is gone because, well, we don't have nothing down there. But if you were to do a n equals 3, you know where to get that. And that's it. That's your program for an n-order 2 system. So this is what I'll be expecting to see for number 5. Number 5. A couple equations with pluses right here. They have to have pluses. I gotta see those pluses. Unless you do minus. Nah, actually, no, it has to be plus. Has to be plus. And note that there's no minus signs here. We're looking at the next state. So there we go. And let's create a figure. Figure 1. Stem the time. And Y3 of SS. Title. Let's call it our state space program for Transposed Direct Form II. And there we go. So let's generate that. What happened? I'm missing a semicolon? Huh? Terminate with semicolon. Invalid. I have a double semicolon somewhere. Where? Uh-oh. Okay. Dot times. Unless it doesn't like. Oh, I'm so dumb. There we go. We were trying to multiply an input times some useless thing. That's what I did. Don't do that. All right, there we go. Boom. And there we go. That's our little state space system. And this is totally not the answer to. Well, actually, it isn't. This is a different system. But we have an input, which is If you don't believe me, let's do subplot of, we're gonna do 1, 2, 1. Yeah, let's do that. 1 row of 2 columns. No, let's do 2 rows of 1 column, so it looks fat. Subplot 2, 1 and space 2 stem of x and y 3 ss title. There's a way to do a mega plot. Darn, it's okay. Output. I don't remember what I did, but it's okay. Input. Let's do this. There we go. So this right here is our input of our system, you know, some whatever random input, and this is our output, but it kind of looks the same. Yeah, this filter was garbage. It didn't even do anything. Actually, yeah, it did. Like right here, kind of looks messy, but this here kind of starts looking more clean. Starts looking like a cosine. So the point is, it does something. So that was to prove something. But how is this? Do we know if this is correct? So I will. So okay, assuming that everyone's done the quiz, and that everyone has done at least the first half of the assignment, we will go over a solution. We're gonna call this check. So check our work. So you should be checking your work with the first half of the solution, this assignment. If the second half of the assignment doesn't look like the first, then you did something wrong. So this is our check with df1 block. This is the easiest to implement. Here's our same input and that unit step. So this is just to check something. So we're gonna do 2 and boom. And what did we get here? Let's get rid of this. Oh, oops, that's not supposed to happen. There we go. Let's get rid of this. It's okay. Output. There we go. And boom, does that look the same? Oh yeah. So this right here is our check. This is from the first half of the assignment, and this is from the state spaces. So this is how you can tell that they're the right answers. So that's been established. So now you can do the other block by yourself, exactly what I did right here, but for the direct form 2, which is the harder of the variants. So have fun with that. Now I will go over the MATLAB functions. The MATLAB functions that we're going to be using are the state space function, which is SS, and lsim. So this is where this comes in handy, this equation that we've created right here. So the state space equations, SS equations, can be implemented as follows. So basically we're going to call some system, yeah, it's going to require some SS of A, B, C, D, and some gain of 1. Don't worry about that. And what do we do? Actually, what is state space? If you don't actually note, and before everyone starts like going saying, hey, I don't know what you're talking about, because it's something you need to download beforehand. Note, you need to have the controls installed. So you need to have the controls toolbox installed. If you don't have this, it's gonna say, sorry, we don't even know what SS is. So to figure out if you have it, go to home, go to add-ons, get add-ons or manage add-ons. Actually, let's manage it. And boom, I have a control, DSP. Those are the essentials that I have, that I love. Why did it do that? But point is, go to add-ons and check if you actually have it. This is how you check if you have it. So just type in control, enter, and then here's the control systems toolbox. Click on it, and actually it said right there installed. So this is how, if you have it installed. If it's not installed, then install it. If they're charging you for it, then I recommend it, because it's going to be a good function to have for the future. And this controls box, the DSP box, and I don't remember what else is useful. But point is, those two are the more essential ones in DSP and signal processing for the rest of your EE career with signal processing. So point is, you need to have that installed, because if you don't have that, it's going to say, sorry, we don't know what SS is. It's just going to say it's just whatever. So now that that's been established, what do? Actually, type in help SS. And this right here should tell you some stuff. As in, okay, so we're expecting this. Oh, where have you seen this? Oh, so this is the next state, but don't worry, you already know what that is in your book. A, B, C, D. Woo, right here, this right here. So we're done. So how do we do it? So we're gonna do it like this. Because I want to catch up on time and not waste too much time, let's do this right here. So assuming that you see all those equations right there on the screen, this is what I did. Boom. Haha. That is your state space for an n order 2 system, not an n order 3. So for the third system, you're going to have 3 equations. So you're going to have like a matrix of 3. So it's going to be like A is going to be a 3 by 3 matrix. So what I did right here for A is I did 1 row. So this comma just says, okay, here's 1, and then we're going to go to the next one. This right here just says, okay, we're going to start a column. I put this ... which just basically says continue to next line. So it just treats it as this. So you can either do this. This is also okay. So this right here is 1 row, 2nd row, but I like seeing pictures. So I do this and boom. And that looks like a square. So for the actual problem, you're going to see a 3 by 3 block. So this right here is a 2 by 2, but for the third problem, you're going to have a 3 by 3 block. And then this right here is a same thing too. So if you want to see that. So that right there is B, which is this right here. So that right there is 2 rows of 1 column. So here's 2 rows, 1 row, 2 row. So I do this because I like visual stuff. Here's C, which is this right here, and D is just the gain. So there you go. You are done. Now, all you gotta do is press enter. Okay, editor run section. Boom. So if you want, I would like to see these outputs when you generate them, so then I can know that you've done the assignment correctly. And there's your gain. Oh, what's 2545? 2545 comes from, aha, don't cheat, I will see this. So that's why I'm requiring everyone to turn in their M files. So you can screenshot this, or you can just leave it semicolon. Don't put a semicolon there so I can see that. So now you have your state space equations. Now what are we going to do with them? So let's do the following. So now you have your system. Now we got to do graphs, graphs. So actually you can do this on the same thing. So let's do, I don't know, y YOLO is equal to lsim of our system. With our input, we need to throw an input and our time. Here we go. And let's actually suppress that one because this is going to throw us numbers. So this is our system. This is our input. What's our input? Which is, this is our input. And this is our time. So we're going to look at time. So time starts at -2, -1. We have nothing there, but don't worry. So, and let's do this. Just to save some time because we are almost to an hour. There we go. Control enter. Boom. And that's how you do it with state space equations. It's really nice and clean. Whereas you have like this, which is pretty wild. But this is the MATLAB way of implementing stuff. It looks more cleaner. It's simpler. This is a comment using MATLAB controls toolbox. These 2 equations. And how do we know? We go to check answer. Here's our first half of the solution, second half of the solution. They look the same. So They have to be the same. If they're not the same, you did something wrong. So that's the check. Make sure everything looks the same, and don't copy the same answers into the. I will catch that too, because as you can see, here's Y1, here's YOLO, which is a different Y, here's Y3SS. They have to be different. I need to see these to be different. If you can reuse them as long as you do this, but preferably try to do this. Oh, I'm getting messages. I should be blocking that. The point is, you have to have this is the state space equations, some checker, and the actual implementation of your program. So I think that is about it for that. Okay, actually, you noted that this thing comes out, and you're like, warning, simulation. So I'll teach you a cool trick, how to make MATLAB like be quiet for 2 seconds. So there's a way to check for warnings, and we can do the following. Oh, Control R, nope, Control T, there you go. So we're gonna call some variable W. Actually, let's not call it W because you probably called it for another node. Let's call it var, you know, whatever. Var. Actually, let me show you something cool. Actually, W. So you note that this it says press Shift Enter. Only do this if you know what's going to happen. Shift Enter, it does that. So that's a cool little trick to know. So this is going to give us the last warning, which is this. And then this right here says, okay, let's identify what that warning is. Actually, let's unsuppress it to see what it does. Let's do this. Okay, so let's run section. So let's see what it says. So it says, this is the warning. So the warning is this. It doesn't like the start time. So I was like, okay, so how do we make it be quiet? So if we detect this this warning, tell it to turn it off. And then let's Control Enter. Actually, let's turn off this, and let's Control Enter. And now it just stays quiet. So now we don't have that warning. So that's how you make some nice little MATLAB things. And note, we do have some orange ticks right here, but that's reasonable. It's okay. I'm fine seeing that. What's this about? It says this might be unused. Oh yeah, don't worry about that. Unexpected use. It says, oh, it thinks this is a scalar. Okay. And that's how you keep your MATLAB codes clean. What's this? The variable C appears to change. Oh, because we forgot to allocate memory. This is the it says consider pre-allocating for speed. So that's the warning you get. So don't forget to pre-allocate. But this is just a quick example. So that is about it for how to do Q5, question 5, and question 6. Question 6 is going to be this. And what did I say for question? Where is that file? I have the assignment on here. Hold up. Give me a moment. All right, assignment 2. I did try to update it a little bit. So, oh yeah, as you can see. So we already did number 4, which is a lot of hand calcs. So if you do need to do it on a separate sheet of paper, just make sure you scan it and that I can see it, and box your matrices, your A, B, and C, and D that you can put into a code. 5, you're going to be creating programs, 2 of them, because there's Direct Form 2 and Direct Form 2 Transposed Direct Form 2, and 4 inputs, so that's easy to change. And you're going to be using the MATLAB functions, where it's, so basically I just did kind of this. You're going to do the same thing with these other 2, and that's really easy. Just change the input. So that is about it, and this should get you through the entire system. I do expect the entire assignment, I do expect that 1, 2, and 3 are perfect. I already showed you how to use the built-in filter function. This right here should look at like this and this. So make sure your equations look like this. If you want to know the answers are in the book. That's where you just literally have to study the book. I'm telling you all these tips because there's an exam coming up, I think Monday. read the book. It's a really informational book. Not the Shams book, Dr. Stewart's unpublished book. So just take the time to read it, and you guys will be golden. MATLAB is supposed to be your friend, and I'm trying to do my best to integrate these videos with those. So 1, I expect perfect. 2 is definitely a perfect. And 3, I expect some perfection, but make sure you can do it. And I think everyone has the filter function. 4, I expect to be a perfect. And 5, everyone should be able to do this. It's not that bad. I already did the transpose one for you, so I expect everyone to get the transpose correct. And make sure you title it too. And this, make sure to at least get the controls box toolbox to turn on, or I don't know how an Octave can do it, so Octave people, try your best. But I do expect to see this one also correct too. So as long as you have number 4 right, if you get 4 perfected, it has to be perfected. I'll be lenient with my grading for number 6, and actually I expect number 5. Everyone should be able to do number 5. Number 6 is half and half because it is a special program, but point is number 4 has to be perfect. So make sure you box your answers. If I don't see box, no points. Just kidding, but I expect to see box answers, nice clean work. And if you have to, you can use 2 sheets of paper, for one for each block diagram if you need to, and that should get you through the whole assignment. So that's everything I have for today, and let's play some quick outro music. There we go. All right, take care everyone.